When people hear the word memory, they often think of just one thing: RAM. But RAM is only one member of a much larger family. Inside every computer are several different types of memory. Although they're all called memory, they perform completely different jobs. So let's break them down. We'll begin with the type of memory that's responsible for keeping almost everything you own on your computer: storage. Whether it's a document, a family photo, a downloaded game, or the operating system itself, they all live in your computer's storage. Modern computers usually use one of two main storage devices: an SSD or a hard disk drive. Both perform the same basic job. They permanently store information, but they do it in very different ways. A hard disk drive, often called an HDD, stores information on spinning magnetic disks. As those disks rotate, a tiny reading head moves across their surface, finding and retrieving the information you request. But because the disks must physically spin and the reading head has to move, retrieving information takes time. An SSD, or solid-state drive, works very differently. Instead of moving parts, it stores information inside electronic memory chips. Because nothing needs to spin or physically move, an SSD can find and deliver information much faster. That's why modern computers using SSDs often start in just a few seconds, launch applications quickly, and generally feel much more responsive. Whether your computer uses an HDD, an SSD, or both, their purpose is the same: to permanently store your data until you decide to remove it. Every time you press the power button, your computer performs a series of checks before anything appears on the screen. But how does it know where to begin? The answer is another type of memory: ROM. ROM stands for read-only memory. Its purpose is very different from storage. Instead of holding your personal files, ROM stores the essential instructions your computer needs before the operating system can even begin loading. The moment power reaches the processor, it immediately looks for these instructions. They tell the computer how to check its hardware, how to recognize devices like the keyboard, storage drive, and memory. And finally, how to locate the operating system stored on your SSD or hard drive. Without these instructions, your computer wouldn't know what to do after you pressed the power button. It simply wouldn't start. Today, most computers no longer use traditional ROM chips. Instead, they store this startup software inside flash memory. This allows manufacturers to release updates that improve compatibility, fix problems, or add new features. You may have heard people refer to these updates as BIOS or UEFI updates. Although the technology has changed, its purpose remains the same: to give your computer the instructions it needs before anything else can happen. Only after those instructions have finished their job does the operating system begin loading. And that's where we arrive at the type of memory most people already know: RAM. RAM stands for Random Access Memory. Its purpose is to temporarily hold the information your computer is actively using. Every application you open, every web page you visit, and every document you edit uses RAM while it's running. Unlike storage, RAM only keeps that information while your computer has power. The moment you shut your computer down, its contents are cleared. That's why your files remain safely stored on your SSD or hard drive, not inside RAM. Now let's move to another type of memory that's even faster: cache memory. Cache is one of the fastest forms of memory inside a computer. It's located extremely close to the processor, and in many cases, directly inside it. Every second, the processor performs billions of calculations. Waiting for information, even for a tiny fraction of a second, can reduce performance. To avoid that, frequently used data is placed inside cache memory. Because it's much closer to the processor than RAM, that information can be accessed even more quickly. Most modern processors actually contain multiple levels of cache, usually called L1, L2, and L3 cache. L1 is the smallest, but also the fastest. L2 is slightly larger, and L3 provides even more space while remaining much faster than RAM. Although most users never interact with cache directly, it's one of the reasons modern processors are so efficient. Now let's look at a type of memory designed specifically for graphics: VRAM. VRAM stands for Video Random Access Memory. Instead of serving the main processor, VRAM serves the graphics processor, or GPU. Whenever you're playing a game, watching high-resolution video, or editing images, the graphics card constantly needs access to visual information: textures, images, video frames, lighting data, and many other graphics resources. Rather than storing this information in your computer's main RAM, it's stored inside VRAM. This allows the graphics processor to retrieve it quickly without competing with the CPU for memory. Graphics cards with more VRAM can usually handle larger textures, higher resolutions, and more demanding visual workloads. But just like regular RAM, having more VRAM doesn't automatically mean better performance. It depends on how it's being used. Next is a type of memory that isn't actually a physical memory chip. It's called virtual memory. When your computer begins running low on RAM, the operating system creates additional working space by using part of your storage drive. This temporary space is known as virtual memory. It helps keep programs running, even when physical RAM is nearly full. But because storage devices are much slower than RAM, using virtual memory also slows the computer down. That's why opening too many applications at once, or running memory-intensive software, can make a system feel less responsive. Virtual memory is useful, but it's really a backup plan, not a substitute for enough RAM. There are also smaller memory chips throughout a computer. Your motherboard stores firmware settings. Your graphics card has its own memory. Even devices like printers, network cards, and game controllers contain small amounts of memory that help them perform their specific tasks. You may never notice them, but they're working every time those devices are used. So why does a computer need so many different types of memory? This is because no single type can do everything well. Some memory is built for speed. Some is built to store enormous amounts of information. Some is designed to remember data without power. Others exist only to help the computer start. Each type has its own strengths and its own purpose. Together, they allow modern computers to be both fast and reliable. So the next time someone mentions computer memory, you'll know they're not talking about just RAM. They're talking about an entire system made up of different types of memory, all working together to keep your computer running.